Hello, hello. Good morning, everyone. Am I audible? Hello. I'm audible? Okay. So, last classes we have done all those flats, labs, all those calculations also. Today we'll start with gantry girders. Okay. So, so if I show you gantry girders. So slow. Okay. So today we are going to start with gantry girders. Okay, so what are gantry girders? If you see in these figures, what are gantry girders? Gantry girders are these are the laterally supported, these ones. These, okay, these are the laterally unsupported beams which will carry your heavy loads from one place to another to carry from here to here. If you see, okay, these are your gantry girders. These are your rail sections. Okay, so these rail sections are moving in this way. Okay, above the gantry girder, and your these are the rail sections which are moving in this way. Okay, and above the rail section there is a trolley which is moving from this side to this side. Okay, so these are your gantry girders. This, okay, if I show you, suppose I say this figure. Okay, if I show you this figure here, you see, yeah, these are your gantry girders which are laterally unsupported. Okay, and these are used for carrying heavy loads from one place to another. In industrial buildings, you will see such as factories, workshops, lifting or lifting. Suppose we have to carry some huge materials when we are constructing on some sites, right? On a site, okay, equipments, huge equipments you have to carry, or at the construction sites or within the building only, you have to carry some very heavy loads from one, carry your heavy loads from one place to another. In that case we require a good gantry girder. Okay, so you see here, this is your gantry girder. Above that we have, this is your rail section. If you see in this figure, this portion, this is your gantry girder, which is your this is your gantry girder. This above the gantry girder is the rail section which is moving in this way from here to here. These two are the rail sections which are moving from here to here. This is nothing but this one, this rail section here. If you see from this side, you will see this portion I, this one, gantry girder, this one, rail section, this portion here, this one, okay. And now this rail section has a crane girder. This crane girder has also a trolley. This trolley is moving from this side to this side above the rail section, sorry, above the crane girder. Okay. This is your crane girder. Here is the rail section from where your crane girder is moving from here to here. So here you see, this is a gantry girder, this is a rail section, this is a crane girder here. Trolley is here above or below. So this is the trolley with the hook. Okay. So this is your gantry girders. We have to design this gantry girders. Okay. Now if I show you another video, these are your gantry girders. Okay. These are your gantry girders. I think you got to know properly what is your gantry girders. Here you see these things. Here you see properly. This is a rail section. This is moving from here to here with this crane girder. Crane girder is above this rail section. Okay, which is moving from here to here. If you have to carry a load from here to this, suppose 6 meter away here, which you cannot obviously pick up all those heavy quintals of loads. So what you will do from here, this portion to that portion, you have to carry from this end to that end. So what you're going to do, you're just going to your hook is going to carry, your trolley is going to carry the load, and it is going to be shifted from here to here. And also if you have to carry from here to here, you can carry from your this trolley above, which is above your this crane girder. Okay. Another here. If you see the elevation here, okay, you see here. This is your gantry girder, this is a real section. Here it is a crane girder. Now this is the trolley. There is always a distance from this is your bracket plate, this one. Above the bracket plate, you have your gantry girder, and above that you have, this is the elevation which you're looking, and above that you have the rail section. Now this is the trolley. Your trolley is obviously not going to move till here. It has a minimum distance which should be kept, okay, between the this bracket plate and the trolley here. Okay, this is known as your what? Approach. Okay, which is minimum, this distance is from the center of the trolley to this one. Okay, is how much? Your L1. This distance of the crane girder is, you can give it, will be mentioned to you whatever it is, 4 meter, 5 meter, whatever it is. So here this is the roof clearance. This is general diagram, okay, for the crane system which we have just now discussed here. In this way, there will be a minimum space for the your this thing, the trolley distance between these two, such that because you're going to carry a heavy loads here, suppose big loads like steel columns or maybe steel beams precasted maybe. So obviously you will need some space also that will be large materials or equipments which you are carrying from here to here or from here to there. So obviously this can dash here on the plates, etc. So there is always a spacing left here. Okay, you want to see the top view. If you see, if I can show you, see that time. Here also you can see the top view here. This is your trolley which will be moving above the crane girder, and your crane girder will be moving above the, in this way, above the this girder. Okay, gantry girder. Fine. There will be a hoist hook, you know, that clearance, etc. will know after some time. But one more thing, this one, if we see the loads on the gantry girder, if we see these loads on the gantry girder, you see here how many types of loads are there, uh, except other than the dead loads. Okay, the dead loads which will be here. Other than that, what are the extra loads which are acting on the gantry girder? You see here, this is your, this one is your gantry girder, above which you have the rail section. So you see here, this is the weight of the hook, which is the huge hook which is going to come with the crab. Crab is nothing but your trolley, this trolley which is moving from here to here in the above the crane girder. So your this load is there, one downward load is there, which is crab load, this one, that means the trolley plus the hook. Then we have the weight of the crane frame itself. Then the other things which are other loads which are there are your surge load and braking load. Okay, wheel loads will also be there, we know, because since loads will be here on the trolley, this is going to carry the loads. Okay, the loads will be hanged on the hook. So when this is having load, obviously the load is also going to be distributed in the crane girder as well as the wheels which are moving from here to here. Uh, okay, the rail section, above the rail section. So here also the wheel loads will be there. Two wheels in the crane system, you will see there are two wheels, here and here one, at both the ends, here one and here one. Okay, so these are the wheel loads which are going to come, and other loads which are, those are braking load and the surge load. Now what is your braking load? See this, these are the rail sections which are moving above the, you see, these are the rail sections which are moving above your gantry girder. So obviously, suppose you have to, you are carrying a load and you have to stop now. From here to this position at a 5 meter distance of 5 meters, you are unloading the thing. Okay, so when you're unloading, what happens? You are going to give a brake, and due to that brake, there will be a force developed there, and that is nothing but, that is also giving a kind of load which is nothing but your braking load. Okay, so when you're giving the, when brakes are applied, when your rail sections, that is the crane girder, is moving above the rail sections, when you have to unload the things or you have to load, mostly in your loading unloading time, you will give brakes to your, you'll apply brakes here to your rail section, so that will develop a braking load. Okay, another one is a surge load. This, okay, this braking load is what? This braking load is your, towards this thing, along your rail section, right, along your rail section, and your surge load is this. That means when your this trolley is moving from here to here, then you have to load and unload the things. So when you are loading and unloading, suppose you're unloading now, okay, with the load, with the load on it, the hook, suppose your hook is carrying the load, and your this trolley is moving from here to here, obviously there are some jerkings also when you are loading, at the time of loading and the time of unloading. There is a vertical this thing, due to this vertical load, there are some friction here, there will be vibrations here, frictions here, on the this thing, the your trolley here, due to which we will have a surge load developed here. Okay, your this trolley from here to here, when it is moving, then you have to stop here. Suppose you need to at a distance of 6 meters, suppose you want to shift your this load, unloading, you have to unload here, then this also have to stop here. So at that time also there is a load developed here. Okay, when you stop this trolley here, there is a surge load developed here. Okay, which is transverse to your rail section. Braking load is along the rail section, and your surge load is transverse to your rail section. Okay, according to IS code, now I'll show now according to this gantry girder, according to this and IS 875 here, we will have what? There are different loads, we know. This one, there are different types of load. I told you the vertical forces. Now what are these? You can see this in this table. If you see the type of loads which are present in the gantry girder and the impacts allowed, okay, according to IS 875. Now the first load which will come is the vertical forces, which will transfer to the beam. Okay, and that can be either uh, electronically operated, or it may be hand operated. Okay, so when it is electronically operated, and for your vertical forces which are going to transfer to the beam, there, if it is electronically operated, your vertical loads. Okay, so your electronically operated machine, which is your gantry girder, switch on and off you do, it will stop itself. In that case, you have your impact load which is falling on the gantry girder. We have to take it to be 25% of the maximum static wheel load. Okay, and if it is hand operated, okay, if your machines are hand operated, then your vertical forces which are transferred to the beam, that will be how much impact load is allowed. In that case, it is 10% of the maximum static wheel load. Okay, when it is EOT, then we have 25% of the static load, and if it is hand operated, it is 10% of the maximum static wheel load. Now, similar to this again, for the horizontal forces which are transferred, which forces which are transferred to the rails. Okay, in that case, if you are using here electronically EOT cranes, then what happens? The impact load which are allowed is 10% of the weight of the crab. That means your trolley, 10% of the weight of the trolley, and the weight lifted on the wheels. Okay, you have to keep you have to know these things. Like for the vertical forces, what we got, if it is EOT, whether it is EOT or hand operated, it will be mentioned to you, or when you're designing, you will see yourself what you are designing. Whether it is, if it is EOT, you will give an impact of 25% maximum with the static load, and if it is hand operated, 10%. And for the horizontal force to on the rails, is how much? If it is EOT cranes, then 10% of the weight of the trolley and the weight lifted. It is going to be the impact which is allowed. Okay, it is this much. And if it is hand operated, it is 5% of the weight of the crab and the weight lifted on the wheel. Okay. So when it is vertical forces are calculating, then it is this much of the static wheel load, and here if it is horizontal on the rails, then it is trolley plus your the lifted weight which is lifted on the wheels. Okay. Another one, if you see here, the horizontal forces along the rail. This was your surge load here, and this is along the rail, which is braking load. So, in case of braking loads, the impact which is allowed according to IS 875, here we have 5% of the static wheel load for EOT. Okay, here in the horizontal forces which are along the rails, what happens? It is 5% for both the static wheel load. The impact which is allowed, it is 5% of the static wheel load, as or it can be uh, for both EOT and hand operated. If it is hand operated also, it is 5% of the static wheel load, and if it is EOT, then also it is this much, 5%. Okay. Now, when we are designing an integrator, we have to see some of the things, like we have to know where is our maximum load, where is our maximum bending moments. Okay, So for that and our maximum shear forces, so if I try to show you, let's see, maximum, okay, okay, I'll try and show you. Okay. No. Okay. Hmm. Where should I show you? Suppose here, I'll show you here. Okay. See here. Um, suppose you have this, you have the reactions here. You have the reactions here. This is the crane girder, okay, which I showed you. Um, Now above this, this is the crane system. Here, if I showed you, no, that here you have the gantry girder. This side is your crane girder, and above this you have the trolley. Okay, so this crane girder here will be your maximum load because the trolley is moving. Okay, and the load which is carried is taken by the trolley. So we have to check here in the along the crane girder which is above your this gantry girders. Okay, so here if we see here, this is the crane girder, suppose, and this is the UDL here, the load of the crane girder. Okay, these are the reactions. Now where and how much is your maximum load which is going to be there, which is going to be present there, is somewhere here. Okay, here we will have W, the load, which is nothing but the hook plus your trolley. Okay, this is your hook plus trolley. Here you will have at this corner, you will have your maximum loads. Okay, this is the position in the crane system where you are having a maximum wheel load, and this distance from here to here. Okay, this entire distance is how much? This is nothing but your span of the crane girder. Span of the crane girder. This is the crane girder. You have your reactions here. Suppose this is RC. So if we give the gantry girders to B, suppose this is A, this is Suppose B, this is C, this is D. So now we are looking the, wait, the C, D. Suppose, so we are having, suppose we are going to give here R, C, and this is your R, D, C to D. Okay, so this distance of the uh, crane girder is how much? L. Suppose this is your span here, and this distance, this will be your, suppose this distance is your L1, which is nothing but your hook approach. Okay, so this distance is your hook approach, and what is a hook approach? It is always uh, this is always same. Okay, this distance is always same hook approach, because you know your, this is the trolley plus the hook where all the loads will be taken by this trolley, and which is divided among the crane girders and gantry girders. So these loads are moving from here to here, shifting from here to here, this trolley. We don't know where it is going to be maximum, but we know one position where it is going to be constant, that is this hook approach. I told you when I was explaining that this trolley is moving from here to here, but this trolley doesn't shifts to the ultimate end of this crane system. Why? Because there are some uh, bracket plates are there are gantry girders, and also here in this trolley there are huge equipments, or you can say there are huge structures which are carried by this trolley over this crane and the gantry girder. So those are that much large that if you just, you cannot just come to the edge of your this crane girder. Why? Because you should always have a minimum approach length, because that is a space which will always be there. uh, Beyond this, your this trolley is not going to move beyond that. Okay, why? Because there should be some free space because of the heavy loads or the huge structures which are being taken by the trolley. So this is the hook approach. Minimum hook approach must be there, and this is nothing but this one, this hook approach. That means your trolley is not going to move beyond this point. Beyond this point, it is always going to stop here, because there is a minimum hook approach. Your trolley is this big, and your equipments or loads which you are carrying is bigger than this here. So this will obviously require some free space here when you're carrying this load. So hook approach, a minimum hook approach is always kept here along the for the trolley. So this will be your hook approach, suppose. And you have the reactions here. This is the load, suppose now. And this UDL is how much? This is the weight of the crane girder, which you can say to be W kilonewton per meter. Okay, W kilonewton per meter. This is the load. Here you have the, so what we came to know, we have to know the maximum load where it is acting, and your maximum load where it is acting, it is acting here at the minimum hook approach. Okay, this one here, here at the end will be your minimum. Your hook approach will be given to you in your question. Okay, so this hook approach, at this hook approach you will have your maximum load. Okay, maximum wheel loads are going to be here. So you now know the position where is your maximum wheel load. Any design of the gantry girder you are doing, you have to calculate the maximum wheel load, and the maximum wheel load where it is here at the minimum hook approach. Okay, because we know this constant position that at one time it is going to come and stop here, but the other ones we don't know where it is going to stop. This is so we cannot take the distance, and we cannot find out the reactions and loads. Okay, so this is the thing which is taken, that is your at minimum hook approach is our maximum wheel load. Okay, this wheel load you can say to be kilonewton here, hook plus trolley. So when you're finding out the maximum wheel load in the crane system, because obviously you have to calculate that before finding out the bending moments which are acting here. So the maximum wheel load you're going to form in this way. Your crane system having a UDL reactions, you have to calculate the reactions. This is the maximum load at the minimum hook approach, and you will obviously you can calculate the reactions. Now when you know this load, this loads will be given to you, so crane load you will know. Okay, the spans are also known to us. So in this way you can calculate your maximum wheel load at this position. That means here, if you see, okay, this is the maximum wheel load given to you. Now if I talk about the maximum shear force, suppose you have this one gantry girder. Okay, this is your gantry girder, this was your crane girder, mind. This one, here are your reactions, these are your reactions. Another we know our maximum load we have calculated, where it is here, the maximum wheel loads, but these are on the crane system. Okay, this one here on the crane system, but on the gantry girder you have your rail sections. Rail sections can move to the edges, no problem. So your maximum shear forces will be here. Okay, so if you see, this was your gantry girder A to B. So this will be, suppose R, the reaction will be RA, this will be RB. Reaction here you can see RC by 2, RC by 2, and here RC by 2. Because the reactions which you will get the maximum load you will get from here, when you find out the reactions you will get the maximum load. So when you get the maximum load, that loads are falling on your rail sections also here. On the rail section we have, on this crane girder we have calculated the maximum load here at somewhere here at this point. So we know the, when we got to know the maximum load, we can divide on these two rails, these two rails here, crane girder here. So this is how much, this is your, from here to here, it is your span of the gantry girder. Okay, this is the span of the gantry girder. Here the reactions are RA RB. Okay, so this will be divided, your maximum load will be divided here, which will be distributed in the this gantry girder one leg and this one, that means in the rail section RC by 2. Okay, maximum load we know it is here, so RC we have taken RC by 2. Okay, this was your maximum load. If I suppose I have taken this, so this was your, this point was your maximum wheel loads. You're going to calculate in this way, and these are your, these things are your what, maximum shear force. So in this way, you're going to calculate your maximum shear force in the gantry girder and the maximum wheel load on the crane girder. Okay, here in this way you will have to calculate. Now when you know your maximum wheel load here and the maximum shear forces, you can calculate your maximum bending moment. Okay, so your maximum bending moment, we'll talk in the next class. I think we should talk in the next class about that. Otherwise, this is section B. You can give me your attendance here. Roll number, enrollment 44, 44. Today is 5, 10, 64.
Yes, ma'am. Present. 64.
64, 65, 66. What happened? Hello? Hello? Can you give me your attendances? 64 Kaputara, 65 Limika, 67
64 present, ma'am.
Limika. Am I audible? Hello? Hello? Okay, hello? Was I audible throughout the class? Okay. Okay, for 64, 64, 64,
64, yes, ma'am.
65.
64 and 64.
Okay, 64, 65, 67, 69,
67 present.
69, 70, 70, 72,
Present, ma'am. 72.
73,
73, ma'am.
74, 75,
75, ma'am.
76, 77,
77.
78, 78, 80, 81, 82, 81 present, 82, 83, 84, 85, 88, 89, 91, 92, 93,
Present, ma'am. 93.
92.
93 ma'am.
Okay.
91 present, ma'am. 91 present.
91 present. Okay. 94, 94, 95,
95 present, ma'am.
96,
Yes, ma'am. 96.
97, 98,
98 present, ma'am.
99, 100, 100, 110, 110, 112, 112, 100.